Hello everybody, and welcome to your video notes on Learning Target 6.3 at the basic level. The basic level reads, I can use the kinetic energy equation and potential energy equation, and really we're talking about gravitational potential energy to calculate mass, velocity, height, or energy of a moving object. For this first one, we're not going to have a moving object, but we're gonna have a lot of different examples here. There'll be a total of 4 examples in this video. So the first ones that we're going to deal with are gravitational energy. And remember, the two equations that we have is Eg or EP equals mass times gravity times height, where this is the acceleration due to gravity, which on Earth is 9.8 meters per second squared. In the end, and then we'll have height in meters, and then mass in kilograms. The units for energy are joules. Not like those shiny things, but it's said the same way. Joules, or J for short. And a joule equals a Newton times meters. And then remember, a Newton is a kilogram times meter per second squared. So that's this. And then times meters again. So another way of saying that, because we got meters times meters, you could also say kilogram times meter squared per second squared. Those are all different ways of saying joules, but obviously just saying joules or J is easier. Okay, so back to this. So our first example, and then we'll get to this one next, but kinetic energy is 1/2 times mass times velocity squared. All right, so let's get started with a potential energy question. So 35 kilogram man. So go ahead and pause the video and write down these examples, and then once you have that done, go ahead and hit play. All right, now let's underline the important stuff. So we've got a 35 kilogram man climbs a wall that is 3.6 meters high. That sounds important. And then it says, how much potential energy does he have at the top of the wall? When a problem says potential energy, they really mean gravitational potential energy. So we're going to use this equation. Eg equals mass times gravity times a height. So we're going to solve this for potential energy. No algebra needed. So we're just going to have Eg equals, the mass, so 35 kilograms, times the acceleration due to gravity, which is 9.8 meters per second squared, times a height, which is 3.6 meters. 3.6 goes here. 35 kilograms goes there. Then I would have to multiply these numbers together. And when I type in my calculator 35 times 9.8 times 3.6, I get 1,234.8. And then the units, nothing crosses out. I don't have anything that's on the top and the bottom. So I end up with kilograms times meters per second squared, which, if you remember, this is a Newton. And then times meters. And over here, we said that a Newton times a meter equals a joule. And there we go. So our energy in the gravitational account equals 1,234.8 joules. That's it. So another type of problem that you could have is finding something other than energy. So here we've got 5.8 kilograms. That's important. A box is lifted from the garage floor and placed on the shelf. If the box contains 145 joules of gravitational potential energy, it says how high is the shelf? So I'm going to solve this for H. So I'm going to start with my equation. Eg equals mass times gravity times height. And I want to get H alone. So we're going to do some algebra here. So I want to get rid of mass and gravity on this side. So I'm going to divide both sides by mass times gravity because they're multiplying. And so mass and gravity get crossed out, and I'm left with the, let's see, Eg over mass times gravity equals H. This is the equation we're going to use. Let's switch colors. Green sounds good. So now I'm going to say my Eg, that's my 145 joules, divided by my mass, which was 5.8 kilograms, times G, which is 9.8 meters per second squared. And the number that I get is 2.55, and I'm hoping that I get meters in the end because this is height, but let's go ahead and double check to make sure that the units work. A joule, remember, is a newton times a meter, or a kilogram times meter per second squared times meters. So really I'd have kilograms times meters per second squared times meters here. And let's just switch colors again just to make it easy to see here. So all of this is a joule. So I've got kilograms on the top and the bottom, so those go away. I've got meters per second squared and meters per second squared. And there you go. I'm just left with meters. So that means that we did the problem correctly. So there we go, solving for something other than energy. Now these next two are doing the same thing, but for kinetic energy now. So go ahead, pause the video and write these down in your notebook. And when you're done, go ahead and hit play. All right, great job writing that down. So here we go. We're going to determine the kinetic energy. I'm going to box that in. That's what I'm going to solve for. And then I'm going to underline the things that I need, that I'm given. So I'm given the mass, and then meters per second ended up going off to the side. And I'm given the speed. And we know that kinetic energy equals 1/2 times mass times velocity squared. And I'm just going to plug everything in. I don't need to do any algebra because I'm not solving for anything other than what I'm given. So 1/2 is 1/2, nothing new there. Mass is going to be the 625 kilograms times my 18.3 meters per second. Then all that will be squared. So let me type that in to my calculator. I get 5,718.75, so I'm just going to say 0.8. And then we want joules in the end, but let's see if that works out. Switch to blue. No, blue's not that different. Red. So this does not have units, kilograms though, and then meters per second, and you square that. So you end up with kilograms times meters squared per second squared, which that sounds familiar. Over here we said that kilograms times meters squared per second squared is a joule because of all these other things we talked about. So in the end, instead of writing all this, just write a J. And that's my answer. Now we can do the same thing, but this time we're going to solve for something other than kinetic energy. So let's see what we got. Missy Dyewater, blah blah blah, who cares about the circus? Oh, here we go. Kinetic energy. Had kinetic energy of this just prior to hitting the bucket of water. If her mass is this, what is her speed? We're going to solve this for speed or velocity. So we start off with our equation. We've got EK equals 1/2 times the mass times the velocity squared. We want to have V saying that V equals in the end. So we're going to do some rearranging. First, let's get rid of this 1/2. Multiplying by 1/2 is the same, or the opposite of multiplying by 1/2 is multiplying both sides by 2, or you can think about like dividing by 1/2. Dividing by 1/2 and multiplying by 2, same thing. So I'm going to multiply both sides by 2. So I end up with 2 times EK equals the mass times the velocity squared. I want to undo this multiplication. So I'm going to divide both sides by m. These m's go away. Now here's the fun part. I have now V squared equals 2 times energy in the kinetic account divided by mass. In order to undo a square, and I don't think we've done this in this class yet, but in order to undo a square, you have to do the square root. So I have to take the square root of both sides, and then I end up with V equals the square root of 2 times the energy in the kinetic account divided by the mass. Okay? So, if we just substitute in now, we end up with V equals square root of 2 is 2 times energy in the kinetic account, which is 12,000 joules. All that divided by the mass, which is 40 kilograms, coming from right here. And I'm going to type that in my calculator. And after I do the square root and all that, I'll end up with V equals 24.49, or let's just say 5. And then the units that we want are probably meters per second because that's velocity. Let's double check that. So remember, joules is the same thing as saying kilograms times meters squared per second squared. So what I end up with is, let's change colors again just because I like doing that. We end up with the square root of kilograms times meters squared per second squared divided by kilograms. So this part is all of this, and the kilograms just goes right there. So we've got kilograms on the top and kilograms on the bottom, so those go away. And so then I'm just left with the square root of meters squared over seconds squared. Well, the square root cancels out both of these squares and the square root, so then I'm just left with meters per second. Hey, look at that. That's what I want in the end. And you don't have to do all that, but it certainly helps to make sure that you get the right answer. A lot of you are in the habit of that, so keep it up. And there you have it. There's your answer, 24.5 meters per second. Thanks for listening.